All right, guys, welcome to your video lesson for the day. I am out of the classroom working on actually training for this curriculum, so you guys can maybe get some of the technological aspects available to you soon. So in my absence, I have this video. It'll be posted to the Moodle page, so you can access it at any time. So if you miss anything during class today, you can always fill that stuff back in by watching this video at your own leisure. The sub should pause the video from time to time to catch up. I will be going faster than a normal class because you have the ability to pause the video, okay? So at this point, you should have already done your homework discussion and collected, the substitute should have collected the homework, and he will leave it for me to grade. I'll get that back to you guys next class. And now we're ready to start with our warm-up today. Our warm-up has to do with literal equations, which is what our class was last week. Remember, we're solving for variables. Even when we don't get an answer like 5 is equal to something, we're getting answers that are uncomfortable, but we're still able to do the math. So if we look at the first one here, I'm supposed to solve for p. And you guys are going to have to forgive me a little bit because I'm getting used to using this marker here, squiggling around. So it might look a little sloppy. I'm going to do the best I can. You guys already know my handwriting is not so great. So we're going to give it a whirl here. So if I'm supposed to solve for p, what I notice is that I have p times r times t. And all of that multiplication can get done in one shot, undone in one shot, if I divide both sides by RT. And if I do that to one side, I got to do it to the other, so I divide both sides by RT. Well, that cancels out the RT on the right-hand side, and so I'm left with P on the right-hand side. I'm going to write that first and say P is then equal to that I divided by RT. All right, super sloppy. It's the best I can do with this, but P is equal to RT, or I divided by RT rather, is the best that we can do for this. I can't do any computation. That's the best I can do. When we look at the next one, we got a little bit more going on here. So if I look at C is equal to, in the numerator, WTC, notice the two different cases of C, uppercase C, lowercase c. That's going to be important. I got to solve this for W. So what I'm going to do is I'm going to rewrite the entire equation. C is equal to capital W T C divided by that 1,000. And the first thing I notice is that, well, I can't get rid of any of this stuff until I undo the division by 1,000. So I'm going to multiply both sides by 1,000. So I'm going to do it on that side, and I'll do it on this side. That will cancel out here, and I'm left with 1,000. C is equal to just that capital WTC, right? The 1,000 is now on the other side. And now we have something similar to what we had over here, where I can take care of all of this multiplication by undoing it and dividing by TC all in one shot. So I get TC in the denominator. Those cancel out here. So the answer becomes capital W is equal to that 1,000 C, capital C, divided by lowercase t, lowercase c. So that'd be my final answer for that one here. Let me get rid of this recording and move on to the next page. All right, homework answers already should have been shared and checked with you. I'm going to go through the rest of the slides here, and we're going to get to our lesson. Today what we're working on is creating and solving inequalities, okay? And as we go through this today, what we're going to talk about are the symbols and how they can be used in real-world situations. So what is an inequality? An inequality is a statement that compares two expressions that are not strictly equal to each other. They can be equal to each other, but we compare it with another symbol. And one of the things we got to review is, what do all of these things mean? So what is the less than symbol? Well, less than symbol looks like that. What is the less than or equal to symbol? It's the same, except for we have a line underneath it. That means less than or equal to. Greater than looks like that, and greater than or equal to looks like this. Again, the line underneath indicates that it's equal to. So if I'm looking at like x is less than 5, answers to this inequality are things like 4 and 3 and 2 and 1, even 4.99999, but not 5. if I have x is less than or equal to 5, now 5 is a solution as well as 4.999. But the difference being that 5 can be an answer here, but not an answer here. Okay, and not equal to is just expressed as an equal sign and then a line drawn through it. Okay, so we're going to model this class kind of like we've done in the past, and we're going to work with this question here, saying, all right, well, I have a triangle, and the area of the triangle shown above is no more than, so we got to interpret some words again, no more than 12 square inches. Find the maximum height. Well, one of the things we need to know about this is that area of a triangle is, maybe you remember, 1/2 times the base times the height. Or another one is the same thing, because it's fraction multiplication. Area is equal to base times height over 2. Either one of those will get you the right answer. I usually work with this one. Sometimes this one is a little bit better. So what we got to think about is, now it's not going to be equal to, okay? Because the area, okay, the area of the above triangle is no more than 12 square inches. So what we're going to do is we're going to circle back after some practice, and we're going to be answering that question in just a second. Okay? So let's head on to our next set of slides. What I want you guys to do is actually spend maybe, I don't know, no more than 4 minutes working on the distributive property. One of the things that we need practice on is using the distributive property. And so what the distributive property says is that if I have a on the outside of parentheses and then terms on the inside, addition, subtraction, whatever, I multiply what's on the outside to what's on the inside. So we get our a times b and our a times c. So pause the video at this point for maybe about 4 minutes and try all of these problems 1 through 6. I will tell you that when you get to 6, it is not the same. Obviously, you don't have parentheses. What I want you to think about is, how can you undo this so you can have addition on the inside, a term here and a term here, and some number here that would then create a distributive property problem. I want you to undo this. It's called factoring. Give it a shot. 4 minutes. Pause the video. Do your best. Okay, so you should have had some time to do this. Let's go through what the answers are here real quickly. What this means is that I have 5 times x and 5 times 4, so I have 5x plus 20. This is negative 4 times y times negative 2, so I got negative 4y plus negative 8. Just because this is on the other side doesn't mean anything different. This is 6 times 7 and 6 times a, and I can write it in any order I want because it's addition, so I can have 6a plus 6 times 7 is 42. I can write a different order, it doesn't matter. This one is negative 2z, and then a negative times a negative, remember we can add the opposite here, negative times a negative is positive 12. Scrolling down to the bottom ones, now I don't have any numbers at all, but I can still multiply anything I want. This is c times x and plus c times y. And this was the challenge one. What I was asking you to do is to see what was in common between 7 and 14. If you think about it, the common factor is 7. And if I divide 7a by 7, that cancels out and I get a. And if I divide 14 by 7, I get 2. And now if I redistribute in, 7 times a gives me 7a, and 7 times 2 gives me 14. So we just undid the distributive property to get this expression here. Good job. All right, so let's dig into some inequality stuff. All right. Second here. Okay, things you need to know about solving an inequality. It is the same as solving equations. It's no different. It's exactly the same. It's the same as solving equations. So the equation equivalent of this would be an equal sign, right? So if this said instead 5x minus 10 equals 25, what would you do? Well, you would add 10 to both sides. That's exactly what you're going to do in an inequality. It's no different. So what happens? My 10's cancel out. I'm left with 5x. And now I keep the inequality symbol. It's not equals. I treat it like it's equals in solving them. 25 minus 10 is 15. All right, what would I do if it was an equation? I would divide by 5. That step is still the same here. So my 5's cancel out. I get x is less than 5. 15 divided by 5 is 3. Awesome. Now, there's a thing about graphing that we can do with inequalities. So let me go down a little bit here and give myself some space. I have to graph the inequality x is less than 3. Now here's how I want you to graph these. I don't want you to start at 0. That's bad. Do not start at 0. Whatever we are comparing x to, we are going to put in the middle of the graph. And then all I need you to do is to put numbers, one number on either side of that. So 2 and 4. Okay? So now we've got the start of a number line. If you were going to draw this out by hand, you would just draw out a 3, a 4, and then a 2. And that's all you would need for your number line. Okay? So, how do I graph x is less than 3? Well, when we go back, and I'm going to go back to the beginning here and talk about symbols. All right? Each of these have a circle that's related to how you graph. All right? So the less than circle has an open circle, and that open circle means just what we were talking about here. 5 is not part of the solution. If I say x is less than 5, 5 that's part of the solution. So an open circle on 5 tells us that 5 is not part of the solution. Equal to inequalities, so greater than or equal to, less than or equal to or greater than or equal to, will each have filled in circles. So let's see how well I can color with this thing. Filled in circles here. That tells us that, just like this says, 5 is part of the solution. So we would have open circle here for less than or equal to, greater than or equal to, and closed circles on greater than or equal to or less than or equal to. So now let's go back to our graph. This does not have a line underneath. So that means 3 is not part of the solution. So it is an open circle. And where do all my solutions lie? Where are the values that are less than 3? Well, they're going to be to the left. Now, here's how I want you to do this. I do not want you to shade on the number line. What I want you to do is draw an arrow up and out of the circle, and then in the direction where the solutions are. So that's what I want your graph to look like, only, better written than what I can do with this crappy marker. All right, well, let's go to the next one. Notice here I have you changing this to 17, and that's for a specific reason, for this to work out a little bit nicer. All right. So again, pretend it's an equation. What would you do to solve? Remember, that is a positive 8 because I can add the opposite. Now it's very clear this is negative 3. I would subtract 8 from both sides. So minus 8, minus 8. What does that leave me with? A negative 3x is less than or equal to, that cancels out, right? Less than or equal to 17 minus 8 is then 9. I forgot my x here. Well, what do I do now? Well, I divide both sides by negative 3, negative 3. All right, purposely doing something here, and I'm going to move on. If I leave it, x is less than or equal to what? Negative 3, right? So what would my solutions be if I graphed it? Again, I would want you to put arrows on either side of your number line. Only negative 3 here, and don't be careful when you make your number line that pay attention to the negative. This should be a negative 2, and this should be a negative 4. That's all I need on your number line. This should be a filled in circle on negative 3. Okay, so I filled that in. And where are my solutions? It says x is less than negative 3. All right, so I'm drawing my arrow in that direction. Now here's what we're going to do. We're going to test this. We're going to test this to make sure it's true. Because if we did it right, we should get a true statement, right? If I plug in negative 4 in for x, I should get a true statement. Well, let's try it. Try it over here. So I have 8 plus negative 3 times negative 4. That's supposed to be less than or equal to 17. What does that give me? 8 plus negative 3 times negative 4 is positive 12 is less than 17. Combined like terms, I get 20 is less than or equal to 17. Well, is 20 less than or equal to 17? No, it's not. Now, when you think back to what I said here, I said I'm purposely not doing something, right? What I was purposely not doing is a rule, the only thing that makes a difference in graphing linear inequalities. The only thing that makes a difference is the following slide. And you don't have this, but you need to know this. When you multiply or divide by a negative number on an inequality, you have to flip the sign. Flip the sign, which means if it was greater than, you have to flip it to less than. If it was greater than or equal to, you have to flip it to less than or equal to, and vice versa. All right? So now, let's go back in time here for a second. What should I have done at this point? I divided by a negative. So I have to do what? Flip my inequality. So x is now greater than negative 3. I go ahead and graph it. Negative 3 is here. Forgot my negative sign. Negative 2 and negative 4. Awesome. Now, same deal. Close circle because I can see a line, right? And it's greater than, so my solutions are all to the right. Awesome. Now, let's just test and make sure we get a right answer. Let's test this negative 2 to prove it. So I got 8 plus negative 3, substitute in parentheses, negative 2, should be less than or equal to 17. This gives me 8 plus positive 6, supposed to be less than or equal to 17. And 8 plus 6 is 14, so it does work. Check mark. Awesome. All right, so remember, if you multiply or divide both sides of an inequality, what do? You flip the sign. Flip your inequality symbol when you multiply or divide by a negative number. Awesome. All right, let's do some application stuff here. So it says Zach is planning to send a video game to each of his 2 brothers. If he buys the same game for both brothers and pays $4.75 to ship each game, how much can he spend on each game without spending more than, so he has to spend less than $100, right, and solve an inequality. So here's how I'd break this down. If I were to buy a game for one brother, one bro, I would have the price of the video game plus the $4.75 shipping and handling. But I got 2 bros, so it's going to be 2 times this. So I got 2 times the price of the video game and twice the shipping and handling. So it's 2 times the whole expression. All right. Now, this is the total cost of me buying those video games, or Zach buying his video games for his brother. And what do we know? I can't spend more than $100. Every purchasing thing that you ever do, whenever you buy anything, it's an inequality. You only have a certain amount of money to spend, and you can't go over it. You can spend exactly that amount, but you can't spend less. So, when I'm spending my money, I cannot spend more than $100. So whatever I do spending-wise has to be less than or equal to that $100. And what am I doing to spend? It's 2 times that video game plus $4.75. All right, now let's solve this and figure out how much money I can spend on a video game. Let's give me some more room here. So what do I got to do? Well, this is another application of the distributive property. I'm going to multiply twice, so I get 2 times that V plus 2 times $4.75 is $9.50. That's supposed to be less than or equal to $100. Now I got a 2-step inequality. I got to subtract $9.50 minus $9.50, and I get 2V is less than or equal to $90.50. Divide by 2. Divide by 2. It is not negative, so I am not going to flip the sign. My video game price has to be less than $90.50 divided by 2 is $45.25. So what does that mean? That means that the maximum amount of money I can spend on a video game if I buy the same for each brother is $45.25. Cool. If you need to pause the video, go back to review that, please do. Otherwise, we're moving on. All right, so this is some practice that I want you guys to complete. What I would like you guys to do is pause the video, try it on your own, and then I will show the steps for you guys to finish it up. All right? Go ahead and okay, so you should have had a minute or two to try these problems. If not, pause the video again, keep going. But we're going to move on here with these practice problems. So I have a fraction. Uh-oh. Remember, it's just fraction multiplication, top times top, bottom times bottom. So what do I get out of this? 6 times 4 is 24. X over 3 times the 1 is just 3. Plus 4 times 9 is 36. And then 3 times the 1 is just 1. I'm sorry, not 1. 3. That is a 3. My bad. All right. So now that is going to be less than 4. Well, I can do a whole lot of simplifying. 24 divided by 3 is 8, so I really got 8x plus 36 divided by 3 is 12. That's going to be less than 4. I would subtract 12 from both sides, minus 12, minus 12. That gives me 8x is thus then, and then 4 minus 12 is negative 8. Divide both sides by 8, divide both sides by 8. I'm not dividing by a negative, so the sign stays the same, and I get x is less than negative 1. And if I were to graph that, I probably won't graph the next one, but again, just a reminder, number line, I only need one number in the middle. There's negative 1. This has got to be 0. Here's negative 2. Open circle. X is less than negative 1. Where are things less than negative 1? To the left. All right, let's look at this guy. Same deal. Distributive property. Negative, this is the fraction, right? Negative 2 times 1 is negative 2 over 1 times 4 is 4. X goes along for the ride. Plus, that's a 1 there. And it's really not fraction multiplication. I totally did not need to do that. Negative 2 times 2 is negative 4. Less than or equal to 5. All right, solving in the same way. Actually, I'm going to simplify this a little bit because negative 2 over 4 is negative 1/2. So let's do that real quick. Plus negative 4. And that's 5. All right. So what are we going to do at this point? Well, we're going to add 4 to both sides. Plus 4 plus 4. Negative 1/2 x is going to be then greater than or equal to that 5 plus 4, which is 9. And now this is something that we talked about. How do I get rid of this fraction? It's fraction times a number. I never divide fractions. I have to multiply by the reciprocal. Take the negative with it. Negative 2 over 1, or just negative 2, times negative 2. So that cancels out here, and I get x is. Now, this was negative, which means I have to flip the sign. So x is less than negative 18. Awesome. All right. The next problem's pretty interesting because we get an interesting answer. Maybe you found it out already, or maybe you're confused by what happened. First thing I'm going to do here is kind of add the opposite along the way to make sure that I keep track of my signs. All right. So I have to simplify everything before I start solving. So I have to simplify these parentheses, which leaves me with 4x plus 3 is less than negative x. Nothing happens with that yet. Plus negative 5 times 7 is negative 35. And negative 5 times negative x is positive 5x. I have like terms I need to combine, so I'll do that in the next line. 4x plus 3 is less than. This gives me negative 4x. I'm sorry, positive 4x, because that 5 is positive, my bad. And then plus negative 35. Now check it out. I got a 4x and a 4x. And so if you were doing this problem before, you're probably thinking to yourself, well, if I subtract 4x from both sides, well, what happens? They're gone. I get 0 for those. So this is 0, and that is 0. So what am I left with? I'm left with 3 is less than negative 35. So whenever this happens, this is actually something that can happen. We didn't do anything wrong here. What can happen is we can get an inequality that is either true for all of our answers or is false. So we have to evaluate this. Is 3 less than negative 35? think of a number line. 0 is here, 3 is way over here, negative 35 is way down there. So no, 3 is not less than negative 35. So what we say, this is false. False. Right. Why isn't he writing? False. Why aren't you writing? I have pause it. All right, so here's the deal. Smart Notebook completely crashed on me, so I'm just continuing on without the problem because it completely erased. But what we were getting at is that because what we ended up with was 3 is less than negative 35, we said that this is obviously not true, so we say it's false, and we say that there is no solution then. All right? There is no possible number that could make this inequality true. Now, if instead we would have had 3 is greater than negative 35, like our variables canceled out, right? That's not what happened on this one. But if it did happen and we got this inequality instead, what we would say is, well, yeah, 3 is greater than negative 35, so we'd say it's true. And we say our solution is all real numbers. And what that means is that doesn't matter what we put in for x, everything works. Okay? So we can get our variables to cancel out when we're solving inequalities, and what we can end up with is a false statement. Or, and if it's a false statement, then there's no solution. Or variables can cancel out, and we can get a true statement, and then we have all real numbers as our answer. All right, let's continue on with our lesson here. Okay, so question 13. And we're almost done. We only got 2 more to do here. It says a school band will sell pizzas to raise money for the new uniforms. The supplier charges $100 plus $4 per pizza. The band members sell the pizza for $7 each. Write and solve an inequality to find how many pizzas the band members will have to sell to make a profit. That's key. They got to make a profit, right? So they want to actually make more money than they spent. Well, what are they being charged? $100 plus $4 for pizza. So their costs part is the 100 plus $4 for pizzas, right? Let's say P is equal to pizza cost. Okay, we're just defining our variable here. And now whatever we do, we have to have that cost be less than what we sell. All right, so now we're going to have an inequality for what we sell. And what are we doing? Well, we're selling pizzas, right? And we get $7 for every pizza we sell. And so now we have to solve this inequality and find out how many pizzas that we have to sell. Actually, this variable is not pizza cost. It's pizzas sold. So like an amount. Pizza sold, say an amount. Amount. Okay, so what would we do to solve this? Well, we'd subtract 4p. P minus 4p, and we get 100 is less than 3p. All right, so we divide by 3, and we get kind of a not super nice answer. What we end up with is 33. Let me scroll up here a little bit. We get 33 and 1/3 is less than p. Or, reading it from the variable's perspective, p, the amount of pizzas, must be greater than 33 1/3. Now here's the deal. You're not going to sell 1/3 of a pizza, right? No one's going to buy that. And you can't buy them that way. So we just have to go up to the next whole number pizza. So they must sell at least 34 pizzas. Zaz. Making me hungry. It's 10:30 at night. Wish I could have some right now. Okay. Last question here. Again, if you need more time to write this stuff down, pause it, do it. Otherwise, we're moving on. All right, last problem. This is the beginning problem here. It says the area of the triangle shown is no more than, the area is no more than 12 square inches. Okay? Find the maximum height the triangle can be. So what that means is that we have an area. Area formula, remember, is equal to 1/2 times the base times the height. Well, the base is here. That's 4. The height is here. This is my base. That's my height. So now we have to insert an inequality. So area has to be no more than, which means the maximum area is 12, no more than 1/2 times my base times my height. Okay? Well, now let's just substitute in what we know. We know the area is 12, and that is my maximum height. So whatever I'm doing to calculate area must be less than 12. If I read it from calculation standpoint, this calculation must be less than 12. So what's the calculation? 1/2 times, what's my base? 4, and I'm substituting in parentheses here, times my 2x minus 3 for my height. All right? So now we got to solve this for x. Once we find out x, we can plug it back in and actually find out what our maximum height is. So let's go through it. 12 is greater than or equal to, and in parentheses I have this 4 that I have to distribute. So I have 1/2 times 4 times 2 is 8x. 4 times -3 is -12. And I'm done there. I have the distributive property again. So I have 12 is greater than. Half of 8 is 4. Half of 12 is 6. So 4x minus 6. And now I got a two-step equation that I got to solve. So let's bring this up a little bit. I would add 6 to both sides, plus 6 plus 6. That gives me 18 is greater than or equal to 4x. Divide both sides by 4. And we get, and I'm going to write this differently. I'm going to write the variable first. It's going to be x. And from the variable's perspective, going this way is x is less than or equal to 4.5. 0.5. Okay, now that's not the maximum height. That is the maximum value for x that we now have to use for the height. So what is the height? It is that 2x minus 3. So 2 times the 4.5 minus 3. 2 times 4.5 is going to be 9. Actually, what I got to do here is do 2.5 or 2 times 4.5 and then 2 times 3. So, well, that's not true either. Cross that out. Forget it. Parentheses first, right? So 2 times the 4.5 minus 3 is going to be 1.5, and 2 times 1.5 is 3. Well, there's not something right there. What am I missing? Oh, no. 4.5. 2 times 4.5. Okay. It's, yeah, all right. No. Forget this. Sorry. Again, it's 10:30. I want to go to bed. Okay, so x is 4.5, guys. Sorry. X is 4.5. So what are we doing? We don't need to do what I was just doing. It's 2 times the 4.5. I'm substituting that like this. I would try to use the distributive property. That was incorrect substitution. So 2 times 4.5 minus the 3. 2 times 4.5 gives us the 9. I was correct the first time. I don't know why I second guessed myself. Now we do 9 minus 3, and we get a height of 6. Go back up. We get a dimension here. So hold on. Our dimension, what is it supposed to be? It's supposed to be inches that we can see right here. So I go back down. And we say, all right, 9 minus 3 is giving us our 6. So that means the maximum height of the triangle is 6 inches. Again, if you need to stop, pause, go back, please do. At this point, it is Friday, and you guys have the weekend to work on this homework assignment. So you have pages 65 through 66, numbers 1 through 6, 7 through 19. Only do the odds. Some of you have been doing only do the odds, and then 24 through 25. I hope you guys have an outstanding homecoming weekend. Be safe. Don't end up in the paper. Take care.